Let's see how we can do this following conversion. We have an aldehyde that needs to be converted into an ester. Let's take a look into the number of carbons that we have on the compound that is on the left and compare it with the product on the right. So we have totally 1, 2, 3 carbons, and these 3 carbons are same as these 3 carbons in the product. And the only stuff that we needed to add here is this propoxy group. How are we going to add this propoxy group to this carbonyl carbon? Now, to convert an aldehyde into an ester, we needed to let it undergo nucleophilic addition reaction. Remember, aldehydes and ketones will only undergo nucleophilic addition reaction because these bonds right here, carbon-hydrogen bond and as well as carbon-carbon bond, is going to be strongly basic, and therefore you can't eliminate any of these groups. None of these groups can be eliminated. So what we are going to do here is we are going to first convert an aldehyde into something which is going to have the leaving group. And then we'll replace that leaving group with this propoxy group. Okay, so first we are going to convert this into a carboxylic acid. For that we are going to take chromic acid. For that we are going to take chromic acid.
Please note that chromic acid formula should be H2CrO4. This oxygen should be capital.
We know that when aldehydes are oxidized, this is going to give us carboxylic acid, right? So we are going to convert this into a carboxylic acid first, and then by reacting with thionyl chloride in the presence of pyridine, the carboxylic acids can be converted into an acyl chloride. Now, why we want to convert into acyl chloride is because acyl chloride is susceptible to many reactions, many nucleophilic addition elimination reactions. So let's convert this into an acyl chloride. After we have converted this into an acyl chloride, what we can do is we can react this with an alcohol. Basically, it has to be reacted with propanol in order for the chlorine to be replaced with the propoxy group. Now, how are we going to do this? Where are we going to get the propanol from? We are going to get propanol from propanaldehyde. Okay, how are we going to do this? We know that when aldehydes are reduced, this is going to get reduced to a primary alcohol. So when you're going to use sodium borohydride followed by addition of acid, this is going to give us the alcohol, right? When you add alcohol to this acid chloride, what happens is it is going to undergo nucleophilic addition elimination reaction where the chlorine will be replaced by the propoxy group. Okay, so let's do that. In place of chlorine, you will be having this propoxy group, and this reaction is called as nucleophilic addition elimination. And you can take a look in the mechanism for this nucleophilic addition elimination reaction, where first a tetrahedral intermediate will be formed, and later on it collapses to give you the final product, which is an ester.